Exercise 11.15 gets us to solve quadratic equations, so not to factorize or to expand, but to find the actual values of x. So when we solve a quadratic equation, we make it equal to 0. So as you can see in these are all zeros. So let's take a look at this and how this plays out. So you'll notice that if you have two things that are multiplied together that equal 0, either this one or both of them must equal 0 in order for the solution to be 0. So the question is, what must x be in order for this to be 0? Because if this is 0, anything times 0 is 0, and so the entire equation will be 0. So what would x have to be? So just by observation, we can say, well, this is a 2. Well, if I had a negative 2 plus a 2, then negative 2 and 2 would have to be 0. So negative 2 must be a solution. What about this one here? Well, x here, if x, say, was a 3 and a minus 3 would be a 0. So my solutions are x is equal to negative 2 or 3. And I could write that as x is an element of, and I could just use curly brackets here, negative 2, 3. And that would be my solution. Here's a slightly different one. X plus 5, x plus 7. So again, what would x have to be? Well, if x was negative 5, and here if x was negative 7, then this would be 0, or in this case, this one would be 0. So my solutions are x is equal to negative 7 negative 5. Notice we write it in ascending order. So x is an element of, in this case I'm going to use set builder notation, negative 7, negative 5. Either is perfectly correct.